Okay, so can you see the slides all right?
We can see it fine.
Great. So the first demo is the genome browser. Funding for this has been provided by Trade, and we've developed it together with our partners in Trade, Philips Research, Erasmus MC, the Netherlands Cancer Institute, and the Vrije Universiteit Amsterdam. The idea here is that we wanted to be able to visualize genomic data in tranSMART and then be able to compare genomic variants between different patient cohorts. Also bring in copy number variation data and then compare that with background information that you can get from public service, for example, in code. So because we wanted to have a genome browser that is in place in the GUI of tranSMART, we wanted to have something that would basically use JavaScript or HTML5 to show it right in the user interface. We wanted to be able to drag in high-dimensional data nodes. And as I said before, genomic variants and copy number variation data. I can imagine that in the future we can also, for example, show protein data, but we don't have that yet. We try to use as much as possible open source software. Actually, one of the core principles of the Hive is trying to reuse as much as you can. And in this case, we were able to reuse a Dalian's genome browser, which is developed by Welcome to Sanger, Thomas Dawn. We even had Thomas come over to a hackathon in the Netherlands that we organized with Trade, which was really nice. And he helped us a lot to bring in Dalians into tranSMART. The other component that we brought in is MIDAS, which is another open source software developed mainly by the European Bioinformatics Institute, and which delivers the backend services of showing the genome track data. Both of them are implemented as tranSMART plugins, and the tranSMART core API was also touched. I'll come back to that later when I talk about the RESTful API. So I'm trying to also showcase a little bit the technical background here. Not too much, hopefully. So basically, we have the core DB, which is an implementation of the core API of tranSMART. And then in this case, we use the MIDAS plugin, really, as I said, to bring in the track information that you see in the front end. So as for a demonstration of the feature itself, let me just check. Yeah, okay. So tranSMART 1.2 server, as you've seen before in other demos. We brought in some cell line data, which are contributed by various members within CGMM Trade. And one of the assays we have on this data is a array CGH, basically copy number variation array data. So what I wanted to do now is show this on the genome browser. And all I have to do is drag and drop the high dimensional data there. If it supports the genomic track display, then it will automatically load the tracks in. So you can see here now that I have the losses and gains of genomic regions. If I would be able to zoom out further, then you could see also that the different genomic variations have, of course, different ratios of losses and gains, but I wasn't able to get the demo video in time with that, so just have to leave me on that one. The second is I also can show genomic variants on the browser, which allows me to look in a certain patient cohort, what are the variants in there. So I drag in that node again. What you see here is basically a visualization of the different variants. The pluses here are single nucleotide polymorphism SNPs. I also have insertions, the green ones are deletions, the red arrows, and other features which are hard to categorize and labeled as diverse, like this one that has a mutation that goes from ATAG to AAA. you can click on a variant to bring in more information. Like here you can see this is a deletion where the T is removed in the alternative allele. And I can bring in even my own attributes as demonstrated here by the testing. So one of the nice things that is a little bit hard to see here because I just have two VHF data from 2 patients, but I can actually see what is the minor allele frequency, so the second most common allele, basically, what that allele is and what the frequency is, and that's also shown in the graph here. And with that, I can actually compare my cohort that I've selected with the frequency in the whole study. I have other information like the quality of depth. If I have that loaded in my VCF data, I would also get that here. Of course, I'm also able to navigate, zooming in and out, and I'm able to go to specific genes as well. The scrolling hopefully now should even work on an iPad. That's one of the things we try to fix. So going to a gene is as simple as just typing in the gene name. If we take, for example, human suppressor gene, TP53, you can see here the different variations that I have in that particular gene. And here, okay, so here you can see actually there is a minor allele frequency of half, meaning that we have the alternative allele in one of the 2 samples. Right, so that's it for the genome browser. I guess the idea is that I continue right on with the next one. Okay, so that's the RESTful API. So let me first mention the funders again. So that's Janssen. They funded this development that we did by their in-kind contribution to Etrix, basically. And I'm very excited of this development because what I think is that for tranSMART, if it really wants to become a leading platform for translation research installed at pharma companies, at academic medical centers, at nonprofits, disease foundations, etc., and if it wants to be a de facto data sharing tool, what you need for that is basically first the sound architecture of the whole platform. We also need options, lots of options for enterprise integration, like being able to plug in your own clinical data warehouse or your in-house omics data infrastructure. And you need to be able to connect downstream analysis tools. We'll give some examples of that. And hopefully, with these developments, we can not only have developers developing against the core of tranSMART and putting new features directly in it, but also connecting outside tools like great new visualizations or sophisticated omics analysis tools, which just would use tranSMART as a data repository. So I'm very happy that Janssen funded this coding of the RESTful API. Maybe to quickly highlight the various APIs that we have, the core API is a Groovy API, which is really, that's the innermost part of tranSMART, and it defines the language in which the components talk to each other. tranSMART QueryDB I showed before. This is a reference implementation of the core API, and we have Oracle and Postgres support at this moment. Though likely if you plug in MS SQL, it will work as well, because we're using Hibernate. And then this new development, which I want to show you, is the RESTful API. The nice thing of the RESTful API is you don't need to know anything about tranSMART, the architecture, how it works, to develop against it. The only thing you need is the API contract, which you can find in the in GitHub. So quickly, from a technical perspective, what is the RESTful API? It only uses get in a moment, so it allows you to get data from tranSMART, both low and high dimensional data. It uses OAuth 2 as a protocol for authentication. This is the same protocol that, for example, Google, Facebook uses for their APIs. ProtoOauth, we use that for transferring the high dimensional data. As you can imagine, if you want to transfer microdata over the internet, it's not a very good idea to encode it in JSON, so we use a compressed protocol for that, buffered. And like I said before, this thing, this RESTful API, allows you to build your own tools on top of tranSMART. And we have already 2 implementations, one for R and one for Spotfire that we built together with PerkinElmer, and they're actually selling this, I think, at the moment. But what I want to show you now is the R client. This is an open source R library, which just works against the RESTful API. So here's my R interface. I'm running R on my laptop. And first thing I have to do is load in the library that implements the RESTful client and allows me to talk to tranSMART. Next thing is I have to connect to tranSMART and identify myself so that tranSMART knows who I am and that I can actually get data into this R session. I do that by copying the URL that R generates for me here in the browser. That browser then gives me the login for tranSMART. So I log in with my account, in this case, admin account. And what it gives me back then is a code which can copy paste back into R. So in the background, the OAuth protocol is used, and what happens here is that tranSMART now knows that I am an authenticated user of tranSMART. So the next thing I can do is get all the studies that I have access to. I can do that by running get studies. So as you can see, I get back an object in R which represents the names and the different concept paths of the studies. And next thing, I can, for example, get all the subjects of the study. So let me just first show you the study as you can see it in tranSMART. It's a geo-study which has mRNA data on 55 subjects. I can get the subjects by entering get subjects. And it just gives me all the clinical information that I have with the concept paths as, well, actually the truncated concept paths, so the concepts itself as the column headers and the data in the rows, of course. So with that, I can now actually also get the observations for a specific concept. Using data, I can then go ahead and use the powerful plotting abilities of R to basically make any plot that I want with this data. In this case, I'm plotting the FEV ratio of females versus males. As I said before, I can also use the RESTful API to get high-dimensional data, and R has an implementation for protobuf. Luckily, we didn't have to write that one. So next thing I'll show you is I have some RNA data here in the study, which is called lung. I'm using that name of the concept and matching that with content.match. And with that, I can get the actual microdata. I choose as projection the log transformed intensity values of the mRNA groups. I can specify the word projection. I could also get disease scores if I wanted to, or the raw values. Then next thing is I can use, again, the R plotting functionality to create a heat map of this data. To speed up the data loading, I've actually truncated the mRNA data in the database to only have 55 probes, which then gives me a nice block heat map of the probes versus the patients. Okay, that's it for the RESTful API and the subsequent R client that implements it.